Hello, ladies and gentlemen. Oops. Right, bit of upside down. There. Hello, ladies and gentlemen. My name is Paul Zach. I'm a release engineer with Skyscanner. And the gentleman to my right is Iain, one of our amazing database engineers. The reason my colleague decided to bring me along to a SQL conference is not just to give him a nice intro. Tough crowd. It was because about this time last year, we hit a really unexpected issue. The Redgate Deployment Manager, the tool we've just finished migrating so many of our pipelines to, was announced end of life with only 1 year of support remaining. What to do? We put on our agile hats and started looking at what our current state was. We started with the development part. Our developers use the Redgate development tools. They love the tools. We love happy developers because they're productive developers. So we would really like to keep it that way. The next thing we looked at was our build and package phase. We check out the changes from source control that the developers have committed using the Redgate development tools. And we build them using our continuous integration tool of choice, which is TeamCity. We use the Redgate SQL CI tools to generate the a NuGet package, which we store in Artifactory, which is nothing more than an artifact management store, a really good one. That works fine for us. Our developers know what to expect from the format. Our operational people know the format. They know how to read it. They know how to handle it. It just works. No, we don't want to change any of that. The next phase that we wanted to look at was the deployment phase. Again, we use TeamCity to generate deployment in the Redgate Deployment Manager, which downloads the NuGet package we generated in the build and package phase and deploys the changes to our SQL servers. Because the deployment manager was going to be end of life, we had to change that part. We tried to look for several different tools to replace it without changing the nice part, the front of it that worked for us. We couldn't find any, so we ended up building our own. It ended up being just a set of PowerShell libraries around the SQL release tool that was released earlier this year along with the SQL automation suite.
Thank you. Yeah, you've probably heard a lot about Octopus Deploy already. For a few reasons, we discovered that wasn't going to work well with our aim to make a minimal amount of changes here. So we developed just enough of our own framework to keep what we liked and change what wasn't working for us. So there were two main goals with our deployment framework. The first one was to be as compatible with Deployment Manager in our workflow as possible. We didn't want to have to change everything that our developers and our release people were doing just to make this work. So everything that we build is the same. We're still using the SQL CI plugin for TeamCity. That's working well for us. Everything that we package into Artifactory, that's the same. What we do with it is now changed. Thanks to SQL release, there are some more clever things that we can do there with regards to drift detection. But because the deployment is up to us, we didn't want to have to reinvent that either. So we're reusing native tools as much as possible, things like SQL CMD, things like PowerShell, the central management server, things that our DBAs are already familiar with. We want our DBAs to be able to support this, so we want to use tools they know already. The second major goal is scalability. We have hundreds of SQL servers in a highly available architecture, so looking after each one by one is not actually going to work for us. To encourage this, it's a script-only tool. There is no GUI. This is designed to plug into other GUI tools, maybe, but behind a button. It's automatic, which makes it more reliable and faster, more scalable. If you're deploying to 50 servers at once, you don't want to have to check each of them to see what actually happened if there was a problem. So we aggregate the logs of everything that's happened and bring it into one central place where you can inspect. That saves a lot of time. There's nothing to install on your SQL server. After you've set up a deployment account with the correct permissions to make changes to your database. That's all you need to do. The framework itself does not have any installation process to go through on the agent. You just need to get the scripts available and run them from the command line. There's no hidden registry settings, no configuration files. All of the functionality is available through the parameters to a PowerShell script. So when you're trying to develop a workflow using this framework, you can discover all the features using IntelliSense. That makes it quicker from a development point of view as well. So let's talk a little bit about a typical workflow.
So the first thing we do is exactly what the deployment manager used to do, figure out what machines we intend to deploy to. We use the central management server, which is a feature of SQL release that Ian's going to talk to in just a few minutes. If you don't want to use a central management server to store your SQL servers, then you can just provide the list of machines to the framework through the command line options. The next part is we use the SQL release to generate the update script that we will use to update our SQL servers. This was the point where SQL release really comes into power because it allows us to generate the script and check all the machines for schema drift. That ensures that both the machines that we're going to deploy to are in the same state and that our update script will have the exact same effect on every single one of them. There's nothing worse than having your database servers in a different state and trying to update them. That's a manual task. I'm sorry. No way to go around it. We then grab this, the update script that SQL release generated, and we copy it to the machine and execute it locally. That's a very important feature for us because we want to diminish the amount of network traffic that happens during a deployment. That allows us to both have faster deployments and have them have more and more deployments happening in the same time. We don't hit any kind of MPLS issues. And last, as each machine gets updated, a very important thing is knowing what happened. We take each of these update logs and return them to the executing machine and aggregate them in a human-readable format. If you use TeamCity that we developed it on, you would actually end up with a really nice drop-down list that you can easily query by hand. Another feature that our developers were quite keen on was having the update SQL script available for read. We actually publish it because we execute from TeamCity. We publish it in TeamCity to read it, but you can send it to a central artifact management location, or if you use Logstash, you can send it there.
So that update script is one of the features that we're going beyond what Deployment Manager ever did. It threw away the update script after it was done with it. That made it really hard to debug when things went wrong. So yeah, we built on top of that. So a few things in existing tools that we liked along the way. Central Management Server in SQL Server. If you're using SQL Server, you already have a central management server. It's a central repository of connection information. We've built automation around that so we can query it to get a list of servers in an environment, and that's how we find out what to deploy to. PowerShell is what we're using to make the remote connection to run the deployment scripts. You can use PowerShell. This throttle limit parameter in the invoke command thing is little known, but it allows you to limit the number of machines that you deploy to at once, which if you don't want to deploy to all 100 servers at once, you can say, do 10 at a time, and it just works. We found that using a pool-based architecture rather than a push-based architecture for copying the deployment resources was much more reliable for us in our architecture. So the deployment targets actually copy things from the deployment agent rather than the other way around. That worked better for us. There are a lot of other things that I would like to tell you that what we learned along the way, but this is just a lightning talk, so I don't have time. If you would like to know more, we'll be here for the rest of the day. Here are our contact details. You can also get me on Twitter. If you want to know more about what Skyscanner is doing with technology, please check out our job site. We've got a few openings. And we do plan to open source this framework at some point. We don't have a date yet, but look out on GitHub. We will be putting something there soon. Thank you.